sample and to find the effective stress. Okay, so the reason a clay is different to a sand is because if we have the water table here, not only is everything below becoming saturated, but actually everything above is saturated as well. And this is caused by something called the capillary effect. I'm not going to explain it here, you can go Google it if you like, but it actually forces everything above the water table to be saturated. Now, just a quick note, just on convention, because we essentially define everything below the water table as positive, we need to then define everything above the water table as negative. So you'll see where that'll come into play, but it's just important we make that distinction. So, let's find the effective stress at A. I mean, at A, not X, at A. Okay, so, at A, the total stress will equal the depth, so 2 times gamma sat, and gamma sat we've been given is 19.7, so we get 2 by 19.7 is 39.4 kPa. And now the pore water pressure, because our convention is now we're going up from the water table, normally we go down, so it becomes positive, but because we're going up from the water table, it's actually negative. Okay, and we're going up to a point 2 meters below the surface. So in other words, and because this depth is 5 meters, we're going up 3 meters. Okay, so the pore water pressure will be minus 3 by 9.81. Okay, which is minus 29.4 kPa, which means that our effective stress, sigma V minus the pore water pressure, okay, which is going to be 34.9 minus 29.4, so that's going to turn into a plus, so it's 34.9 plus 29.4, we get 64.3 kPa. Okay, so it's very important we realize that when we're above the water table in a clay, this becomes negative, and it's the distance from the water table to our point is negative, which actually makes the effective stress increase. Okay, so that's at point A. Let's do point B now. So point B, the total stress, we're 8 meters below the surface, and it's all saturated, so it's just going to be 8 times gamma sat, which was 19.7. So we get 8 by 19.7 is 15.8 kPa. The pore water pressure will just be the depth from the water table, so we are 8 meters below the surface. Because this layer is 5 meters, we're 3 meters below the water table, so it's going to be 3 by 9.81. So 3 by 9.81, we get 29.4 kPa. Sorry, I've made an error here. This is 157.6 kPa. Just there, sorry. It wasn't 15.8, it's 8 by 19.7, which is 157.6. The pore water pressure is 29.4, which means we can find the effective stress, which is the total stress minus the pore water pressure, which is 157.6 minus 29.4, which will equal 128.2 kPa. Okay, just before we finish, okay, that's good. In the next video, I'm just going to look at one other special case, which I also recommend you look at. But if you get this sand and clay stuff down packed, you should be good. Hope that helps.